Welcome back to the build of my Rans S-20. I know it's been a while since I've had a video come out, but I've been busy with another big project. But I've achieved a milestone. I got the engine installed. So let me show you how I got here and installed the engine and all the hoses and the radiators and the boot cowl and the Glareshield and the cowling. So lots been going on. Let me show you how I got here. I made it to Sun and Fun this year, but unfortunately, they don't sell those little windsocks anymore. So I just made one myself. I think it turned out okay. Previously, when I was mounting everything to the firewall, I had just temporarily bolted up the engine mount to make sure everything cleared. So now to permanently install the mount, I first had to remount the welded steel sleeves and apply the core band to prevent any corrosion. A Q-tip works great for this. And now for the next big milestone in the project, mounting the engine. After unpacking the engine from the crate, I got it up in the air and tried to get as many components mounted as possible before bolting it to the engine mounts. The Rotax ring mount was a little bit of a jigsaw puzzle to get lined up just right. It initially interfered with the coolant hoses between the cylinders and the water pump, so I had to remove and remount a couple of the fittings on the water pump to get them pointing in the right direction. I also needed to get the electrical harness Octopus with all its big connectors threaded through the mounts depending on where I had mounted the computer and relay box. Then it was finally time to give the airplane a heart and mount the engine. It dropped right into place with relative ease. I was worried about that one for a long time. And of course I tightened the bolts using a calibrated torque wrench, making sure to click it 3 times. There are a few different places to mount the coolant and oil radiators, and it seems like my research turned up a very diverse set of locations. I couldn't use the mounting location called out by the Rans Firewall Forward kit, as I'm not using their engine bed mount, but instead the ring mount from Rotax. The primary criteria for any radiator is a place with lots of airflow. Often that place is in the incoming air path through the cowling. But an alternate place is in the exhausting air path, which is where I decided to mount both my radiators. I looked at a lot of different positions, especially where others have placed their radiators, but I felt that just getting air into the cowling is paramount, and I didn't want anything to obstruct the inlets. So I decided that the best location for my engine installation would be the bottom of the cowling, in the path of the primary airflow. All of the air in the cowling will be forced through the radiator cooling fins, and the high-speed airflow underneath the cowling is a low-pressure area, which in essence sucks out the air collecting in the cowling. Once the radiators were in place, I could then route all the hoses. Luckily, I used the oil hoses that came with the ULS Firewall Forward kit, even though the radiator was now in a different position. It required a couple adapters to get the fittings pointed in the right direction, but those were easily available online or at Grainger. Oh, and for the fuel and oil hoses, I used stainless steel fittings throughout. What good would using fire sleeve hoses be if then aluminum fittings were used, which would quickly melt in a fire? For the 3 fuel hoses, I had stainless steel braided hoses wrapped in fire sleeve custom made. They were by far not the cheapest solution, but I wanted the extra safety of at least slowing a fire's progression if one broke out. The rest of the fluid hoses were for the engine coolant fluid, the glycol water mix. No need for fire sleeving on these, as a leaking water hose would probably put out a fire instead of contribute to it. The hoses to and from the radiator are big, and per the Rans instructions, I stuffed the included springs inside to prevent any of them collapsing. T's were installed in them to tap off some of the hot water for the cabin heater. Those are the blue silicone hoses. I couldn't find a T adapter from a 1-inch hose to the 1/2-inch heater core hose, so I needed to use a 1-inch T, then a reducer fitting down to the heater hose. It wasn't ideal, as it added another 2 connections per side, but after an exhaustive search, it's all that I could find. As you can see, I used heat reflective sleeves around the oil and coolant hoses where they routed near any exhaust pipe or muffler. I've seen some installations where people wrap the exhaust pipes with that ceramic tape to keep the heat under control, but Rotax is not keen on using that method. We'll see how my efforts work out after I start flying. I made extra effort to make sure all the hoses, wires, and components were securely anchored to avoid any rubbing or chafing in the high vibration area of the engine compartment. After Sun and Fun in Lakeland, I attended a Rotax 9 Series service course and injected installation course given by Lockwood Aviation in Sebring, Florida. Dean at Lockwood puts on an excellent course, and I was feverishly writing notes about the changes I'll need to make and also learn in detail the line servicing procedures. The courses are well worth it if you're building up a Rotax installation, and especially if you're going to be servicing it yourself when you start flying. Fitting and securing the Glareshield and boot cowl to the firewall outer edge is a complex process, with lots of parts that need to fit together and be secured all at once. After one final check of all the wires and components, I started riveting the boot cowl to the firewall from the bottom, then working my way up the sides. I had previously cut, shaped, and drilled all the spacer and attach strips needed around the periphery of the firewall. Those layers provided the much needed structural strength to mount the cowling. A very important step in this process is the sealing of the firewall. Even though the aluminum strips are held very tightly to the steel firewall with rivets, there were still multiple gaps, especially around the curves where smoke from the engine compartment could enter the cabin. So those gaps needed to be sealed tightly. Here I'm using a high-temp gasket seal product from the auto parts store. It was a very messy job, and that red sealant just gets everywhere. The process required rubber gloves, lots of paper towels, and plenty of patience. I'm still picking out that rubber sealant from my Clecos. Then the top skin was riveted to both the firewall and instrument panel frame. Sometimes you just don't have the space and need to bring out the manual riveter. Then the side skins attach using the same method, and as I said, lots of paper towels and acetone. To provide flood lighting for the instrument panel, I'm using LED strip lights. They are powered by this little rotary control unit mounted in the panel. It acts like a rheostat, but it's actually a pulse width modulator, providing much more precise control and greater dimming range. The strips come with adhesive backing, but that won't last long being mounted in tension. So I fabricated little clips, which I painted black and riveted to the Glareshield. Those LED strips are definitely not going to fall down in flight someday. I didn't take video of it, but I then fit up the plexi windshield because I needed to know where the fiberglass hold-down strip would be positioned around the boot cowl. This gave me the precise location of where to cut the foam and black fabric to cover the dash. I used spray contact cement for the big areas and gel cement for the edges. So we'll see how that holds up in the sunshine. While I was at it, I added this vent in the middle for two reasons. It provides an exhaust path for cooling the radios and heater core, with that hot air also adding a bit of defogging capability on cold days. I knew those clothespins would come in handy someday, and of course I used a screen riveted in the opening to keep debris from falling in. The sharp lip of the visor is covered with a cushion strip, which I riveted at both ends and injected glue along its full length using a syringe. And the final touch was to paint all the rivet heads flat black so as to not reflect off the windshield. So, that's done. I think it came out looking pretty good. What do you think? The fiberglass cowling did require quite a bit of fitting, as the edges were just rough cut and there weren't any holes cut out. It was all about measure, cut, test fit, and repeat. And did I mention that I really hate working with fiberglass? So many of those glass fibers to get in your skin, eyes, or lungs. I turned into a mummy every time I got out the Dremel saw or sander. Yeah, sorry, no pictures of that one. While I was at it, I riveted in anchors for the landing light and forward camera wires. This keeps them away from the vibrating engine and hot exhaust. Then I used weatherproof connectors to allow for a quick disconnect of the wires when removing or installing the cowling. Once all the edges were fit to shape, I sprayed the inside with some white, high-temp paint in an attempt to keep the fiberglass from charring. We'll see how this works, as the directions say it needs to be baked at 400 degrees to achieve a hard cure, way too much than the fiberglass can stand. Fingers crossed. And because the base color of the airplane will be white, I coated the outside with multiple layers of white primer while filling and sanding imperfections between layers. I was looking for a landing light to use, and even though there is a vast selection of LED lights for the off-road crowd, I heard lots of stories about how those are very electrically noisy, and I don't want my comm radios knocked out every time I turn on the landing light. So while I was at Sun & Fun, I bought a wheel-in landing light to fit the cutout of my cowling. It's a little more expensive, but it's designed specifically for the aviation environment, with its tolerance of high vibrations, low air density cooling, and sensitive avionics. I also bought an optional lens kit, which offers various beam widths. We'll see which one works the best. I mentioned that I've been working on another big project, and that's a hangar. As soon as we moved back to Texas, I added myself to the wait list at all the local airports, and finally a double hangar with an apartment became available. Luckily, it was only half an hour from home. But it was in very, very rough shape. It was neglected for a long time, and the apartment was totally trashed by squatters. So to build it up as a shop, my third one during this build, there was a lot of work to be done. It sorely needed lots and lots of cleaning, electrical work, plumbing, drywall, and painting. I'm nearly done, with a goal to at least have a good, adequate shop and a working bathroom and break area. This has taken me away from working on the plane, but I just swapped a fuselage for the wings in my garage, so the next big project is to cover the wings. So as you can see, I've been pretty busy. But at least I got the engine all installed now, and I can move on to the next project. But in my next video, I'm going to cover specifically the engine electrical system and the interface to the Garmin avionics, because I believe it's a pretty important process to go through. I know I've received a lot of comments that you guys like my tips about the avionics, so I'm going to go into a lot of good detail.